Relax. Leave this video in the background and go do another activity. Study, work, or just rest. I will tell you the story, most incredible you've ever heard. A story that changed the way I see everything around me. Is the story of how the whole reality literally emerged. Of absolute nothingness. Imagine for a moment 13.8 billion years ago. Time did not exist. Space did not exist. Galaxies did not exist. The stars, the planets. The teacher didn't even exist. It was the purest nothingness you can imagine. Before relaxing, if this content helps you, while studying, you work or do other activities, subscribe now. It only takes 2 seconds and helps us enormously. Because what I'm going to tell you, it is not science fiction. It is the most brutal and beautiful reality you can imagine. In an instant that lasted less than it takes you to, everything we know emerged. And when I say everything, I mean to every atom in your body, every drop of water you drink, every ray of sunlight. It is as if someone had turned on the switch, most powerful in the cosmos. You know what the craziest thing about all this is? That the most brilliant scientists on the planet are still unable to fully explain. How can something come out of absolute nothingness? It is as if the boy will watch jealously the secret of his birth, like a cosmic safe that no one has been able to open. I assure you that when you finish listening to this story, you will never see the stars in the same way again. Every time you look at the night sky, you will remember that you are seeing the remains of the most epic explosion of all time. Edwin Hubble, that genius who changed forever our understanding of the cosmos, was the one who gave us the first clue to this story. Incredible in the 1920s. This American astronomer pointed his telescope at the most distant galaxies and discovered something that completely his mind. Galaxies were moving away from us, as if the whole universe was a giant balloon that is inflating but waits. Because this coming is even more incredible and will make your entire existence. If galaxies move away, that means that they were closer before. And if we continue to rewind this cosmic film backwards, we reach a point where all the observable universe fit in a smaller space than the head of a pin. Imagine all the matter in billions of galaxies, compressed into something so tiny that you could not see it even with the most powerful microscope. It's as if you've brought in all the oceans in the world in a drop of water. But here comes what really makes my hair stand on end. Before that time, there was not before. Time itself began at that instant that we call the Big Bang. Is like trying to go further north of the North Pole. It simply does not exist. Scientists have discovered what to look for before the Big Bang. Is like asking the air what color it is. Stephen Hawking, that wheelchair-bound genius who unraveled the of black holes, explained this brilliantly. I will give you an analogy that will help you understand this madness. Imagine you are watching a movie, but not just any movie, but the film of existence. The Big Bang was not the first chapter of that movie. Was the moment when someone turned on the projector. Before that, there was no screen, there was no projector, there was no cinema, there was nothing. It was as if reality itself was waiting for its turn to exist. Don't you think absolutely unbelievable that while you are listening to this, you are part of that cosmic movie? Now comes the part that fascinates me, and it terrifies me at the same time. No one knows exactly how it all began. Scientists have clear theories, but they are like detectives, trying to solve the perfect crime without witnesses, no fingerprints. Without physical evidence, some say that perhaps there was no real beginning, but that paradise has always existed in eternal cycles, like a cosmic roller coaster that rises and falls for eternity. Is like that song that never ends. There is always another verse, another stanza in this symphony of the cosmos. Other brilliant scientists propose something even crazier. That our grandfather is just a bubble in an infinite ocean of bubbles, each with its own physical laws. Is as if we were inhabitants of a gigantic soap bubble floating around in a cosmic bath filled with millions of other bubbles. Roger Penrose, that great ass, even suggests that the hero loses the notion of time at the extremes, becoming equivalent regardless of size, is like a chess game, which is played in the same way on an aluminum board, or on one the size of a soccer field. And here comes something that sounds like pure science fiction, but it is real science. Superstring theory suggests that our universe emerged from a collision between higher dimensions. Imagine that we live on a sheet of paper, but that roll is just one of many leaves in a book, 11-page multidimensional. When two leaves collide, they go. A new toy is born. It's as if we were comic book characters that suddenly come to life when the pages are touched. But let me tell you something that keeps me going, awake at night. Maybe there is something else, something hidden in some corner of mathematics, or the physics that we have not yet illuminated. It's like the monster is a gigantic puzzle, and we would have found the corner pieces. Every time we believe that we understand everything, the cosmos shows us a new card, shows us a new trick we had never imagined before. Don't forget to subscribe, because the next tip will blow your mind. But what we do know for sure is that 13.8 billion years ago, the really started, and now I'm going to tell you what happened in the first moments, when everything was hotter than your wildest imagination. You know where the hottest place in paradise is. The answer will surprise you completely, because it is not where you think. You would think that the hottest place is at the center of a giant star, where temperatures reach 15 million degrees Celsius. That is enough to incinerate anything in an instant. How to put an ice cube in molten lava, but wait. Because this is just the beginning of this heat story. Extreme supernovae. Those stellar explosions that are like cosmic. Temperatures reach 100 billion degrees Celsius. 100 billion degrees Celsius is like comparing a candle to a forest fire. But here it comes. What really my mind when I discovered it. The highest temperature ever recorded. It was not in a star or a supernova. It was here on Earth, 100 meters underground near Lake in Switzerland. In the Large Hadron Collider of the Rim, those mad scientists managed to create a temperature, 5.5 trillion degrees Celsius. By a fraction of a second, it's as if they brought a pinch from hell. Cosmic to our planet, imagine. 50 times hotter than a supernova. All contained in a smaller space than a chia seed. But not even that extreme temperature is the absolute limit. There is something called Planck temperature, which is how the final mercury thermometer is 1.4. 141 million billion degrees. Is such an absurd temperature that when you reach it, it is the particles themselves by their own energy. It is as if reality itself said, "This is as far as I've come." Max Planck, that great killer physique he discovered. This diabolical temperature was one of the founders of quantum physics. Its revolutionary ideas about how light comes in discrete packets of energy, like candy in a bag, laid the foundations for understanding the atomic world, but also led him to consider the fundamental limits of everything in the universe. It's as if I've found the rules of the cosmic game, written in the language of mathematics, Planck. Define not only the maximum temperature, but also the smallest possible distance. 1.6 Gray 1035 Mir, which is 100 quintillions of times smaller than a proton, is like comparing a bacterium with the entire solar system, and the time it takes for light to travel that distance. It's Planck time 539 x 1044 seconds. Is such a ridiculously short time that if 1 second were the size of the observable mirror, Planck time would be the size of an atom. These numbers may look like crazy mathematicals, but Planck temperature plays a crucial role. In the history of the championship, in the immeasurably small moment of the Big Bang, when everything was more compact and warm than anything you can imagine, the temperature approached this Planck temperature. It is as if the boy would have been born in the most extreme sauna of all time. This extreme temperature influenced the formation of the first particles, subatomic, and the expansion of the universe. Is as if it had been the mold that gave shape to all the reality we know today. While you are there, listening to this relaxed in your chair, it is hard to imagine that the atoms in your body were born in these infernal conditions. Every particle that forms you passed through that cosmic fire baptism billions of years ago. The universe in which we live is constantly expanding, becoming less and less dense, as if it were a loaf of bread baking in the oven of space-time. This cosmic expansion has been a continuous process throughout the history of the championship. Scientists still do not know whether the discovery is infinite or finite. Is like wondering if the ocean has a shore. When you are in the middle of the sea, seeing no earth anywhere. If the universe is infinite, always existed, like a book without a front page. In that case, instead of having arisen from a single point of view, would have been infinitely large, and would have become less dense over time. Like a soup that is eternally. But our observable reflection, that part of the cosmos that we can see is different, is only a tiny fraction of the total universe. As if we were seeing the world through our eyes of a cosmic lock. The observable paradise is limited by the speed of light and the distance it has traveled since the Big Bang, 13.8 billion years ago. Is like having a flashlight in your throat. You can only see how far your light goes. But as we travel back in time, that observable part shrinks and becomes more compact. How to rewind video of an explosion until everything is back together in a single point. Finally, we come to a time when everything inside the universe, observable, had only one unit of age, Planck time, and a single angle of Planck length. All our observable cosmos was compacted into such a tiny space that would make it look gigantic to a bacterium. At that time, the temperature of the whole cosmos was exactly at Planck's temperature. It was as if the whole boy was a single boiling particle in the pressure cooker. Most extreme moment of existence, this moment. 100 millionths of a trillionth of trillionths of a second, after the beginning of time and space, is known as the Planck era. Is such a long and poorly understood period, which is like trying to describe a color that does not exist. The laws of physics as we know them had not yet been fully formed. It was like a game where the rules were being written while the game was being played. the magical dance of cosmic forces. In the current universe, everything you experience is governed by four fundamental forces, who are like the conductors of reality. Imagine you're on your couch watching TV. Gravity keeps you glued to the seat like a magnet. Invisible also maintains the Earth's atmosphere, near the surface, and our planet orbiting around the sun. However, despite controlling entire galaxies, gravity is relatively weak. It is so weak that you can beat her with the muscles of one arm. To lift the remote control, when you touch the control button, invisible infrared light, which is electromagnetic radiation, is projected through your room from the control. The image comes to life in front of you through millions of tiny pixels that emit visible light, another form of electromagnetic radiation, traveling back through the room and enters your eyes. Your own eyeballs are prototypes of evolutionary innovation, but ultimately depend on the properties of the atoms within them. Electrons, and held together by electromagnetic force, atomic, are united by the strong nuclear force, as if they were prisoners in the safest prison of oxygen. Protons and neutrons are forced to stand together in the center of the atom. Not only that, these protons and neutrons are in reality a combination of three smaller subatomic particles called quarks, who are also united by the same attraction. Every atom in your body, on your television, in all existence, depends on this force as the foundations of a gigantic building. As your eyes focus and you get involved with the images that are moved on the screen, every nerve inside your brain shoots up to 200 times per second. All this coordinated electrical potential depends on an adequate potassium balance in your body. As other elements, potassium is held together by the strong nuclear force. But there is something else at stake as well. Potassium is radioactive oxygen, and about 5,000 potassium atoms radioactive light every second. Ation driven by the weak nuclear force, 150 million kilometers away. The core of our sun burns with heat from a stellar oven, powered by the fusion of hydrogen into helium. This reaction, incredibly powerful, is responsible for the heat that keeps the Earth habitable, and on a galactic scale, of the very elements that make up the planet, television, and you. All this also depends on the weak nuclear force. Maybe weak in name, but powerful in scope. Is like a whisper that can change the destiny of the stars. Each of these four fundamental forces, gravity, electromagnetism, and strong and weak nuclear forces, act together to shape our entertainment experiences. Has been the case for most of history. Billions of years of our cosmos. But in the first moments of time, the conditions prevailed to create a set of very different rules, derived from the same basic physical ingredients. It is as if the boy would have been learning to walk before I can run, during the era of great unification that followed the era of Planck. There were only two forces instead of four. But how could this be possible? The key to visualizing this is on a coin thrown into the air. Flips a coin to decide between two options. Equally weighted. Face for a team, cross for the other. The decision is only made when the currency stabilizes. After the launch, when the energy provided by the movement of your thumb and index finger is completely worn out, and the disc for before that. When the coin is still full of energy and spinning through the air or on the table, it is almost impossible to distinguish its two faces. There is only one rotating sphere, unique with its own characteristics. Is like trying to read a book while spinning in a centrifuge. Words become a blur. Indistinguishable. This is exactly what we found when we examined the behaviors of the fundamental forces in higher energies, the energies that were present in the nascent universe. Increases the temperature, and the individual properties of the nuclear force, weak and electromagnetic force, begin to weaken and confuse with each other. We no longer see a different face of electromagnetism and the cross of the weak force, but the faceless spinning force of the two united, the so-called weak electroforce. It is as if two rivers meet and become one. Impossible to distinguish which was which. Further increases this energy, and the rotating coin concept is reapplied to strong force and electro-weak force. With sufficiently high temperatures, these are also confused into a unified whole. In a known process, as a great unification, this final unification of three of the main fundamental forces gives rise to what is known as the electro-strong force. It is as if the four strings of a violin to become a single string that produces a melody. Completely new. This theory of the great unification of the rotating currency has not yet been experimentally tested definitively. Even though energy collisions inside particle accelerators can point us towards union of electromagnetism and weak force, energies would be needed millions of times greater for the strong force to lose its identity. In the same way, it's like trying to light a bonfire with matches when you need the energy of a volcano. Even the most energetic phenomena in the universe today, such as supernovae and the jets emitted from the poles of black holes, are still 1,000,000 times too weak. And what about gravity, the fourth fundamental force? Will eventually be accepted into unification? That's a question for the wild and was by Planck. And this is yet another problem for theories quantum gravity competitors solve. Is like trying to solve a puzzle when the most important piece is in another language yet. The great unification theory is a strong candidate to explain how the gym works. Right after the Planck era, for a period about 10 million times longer than the entire Planck, the universe expanded and cooled. But it is a testimony of how small it all began that, even at the end of that time, the entire cosmos was even smaller than a single quark. The smallest particle of matter known today. With the latent energy of this compressed cosmos, in such a small space, the temperature reached 100 trillion degrees, a few trillion times higher than the Great Hadron Collider ever thought. Were like the conditions inside the heart of a star, but concentrated in a space the size of a subatomic particle. Were the conditions for the time of the Great Unification, governed by the electroforce and the strange interactions caused by the tiny cosmos, was full of particles going through an extreme identity crisis. Photons were spontaneously transformed in pairs antimatter-matter, creating quarks and leptons, as if they were cosmic mages, pulling rabbits out of a hat. But these nascent particles were desperately ephemeral, rapidly decomposing back into photons. As soon as they were formed, it was like a costume party, where everyone changed costumes every microsecond. Electro-powered messenger nozzles only complicated the picture more, helping quarks transform into leptons. Leptons in quarks, matter and antimatter and radiation. Under the chaotic rule of the Great Unification was a total freedom of energy and matter, of both virtual and real particles, was like a cosmic carnival, where all normal rules were suspended, and anything could turn into anything else. Until a trillionth of a second. After starting the chip falls, temperatures dropped to mere 1,000 trillion degrees, becoming cold enough for the strong force to be lost, for two forces to become three, and everything changes again. It is as if the boy would have been playing improvised jazz and suddenly decided to follow a specific score. And yet there is a problem with this scenario. Although these theories may describe the behavior of the particles in the first moments after the Big Bang, do not explain the cosmos on a large scale that will eventually come into existence. When we compare the initial conditions with the final result of the championship, the Big Bang looks defective. It's as if we have the perfect recipe for making bread. But the end result, out a chocolate cake. In July 2022, the iconic James Webb Space Telescope was well established in around the Sun, 1.5 million kilometers into space. After a trip, distressing for a month, and a deployment and calibration phase that lasted almost a year, was finally ready to begin operations. Real scientists was like a cosmic hunter, preparing for the most important hunt of his life. But when he focused his 18 golden castles in some of the deepest regions of the observable mirror, scientists were shocked. After viewing the images returned by the revolutionary telescope, the American astrophysicist wrote in the scientific journal Nature, who was found awake at 3 o'clock in the morning, wondering if everything he had done was wrong. It was as if I had learned that all his life he had been reading the map upside down. Within a month, these images and comments, Kirkpatrick's, came to life of their own. The fixed speed of light means that the deeper we look into space, the further back in time. And at corresponding distances, only 200 million years after the beginning of everything. The James Webb Telescope saw galaxies. Not only that, but that these galaxies were ordered with much more structure, from which it will be possible to, was like finding fully constructed skyscrapers on a site where you expected to find only foundations. Theories of star and galaxy formation. They had no way of explaining this, and that was what worried Kirkpatrick so much. Unfortunately, soon, their concerns were to cast doubt on the Big Bang, with some media claiming that the next generation telescope had refuted historical theory with its first images. It was as if someone had found a mistake in a recipe and stated that the whole kitchen was wrong. Fortunately, these concerns were unfounded. Alison Kirkpatrick was specifically involved. For theories on galaxy formation, not for the creation of the whole cosmos. The structure, inexplicable, of the first galaxies suggested that one piece was missing in our understanding. But that did not mean that all our knowledge was wrong, was more of a storm in a glass of water than a catastrophe. Scientific, how to find out that you are missing an ingredient in your recipe. Favorite, but the main course is still delicious. That challenge science. From this perspective, the Big Bang Theory is certain. At least for now. However, as an explanation of how the modern universe, the Big Bang, emerged, faces most serious threats that have persisted for a long time. There are phenomena observed in the structure on a large scale of today's that are not yet fully explained. Is like having a beautiful puzzle that is almost complete, but it lacks some key pieces that make sense of everything. One of these phenomena is the average desert temperature. Although the stars burn several million degrees Celsius in empty space is alone a few degrees above absolute zero. The average temperature we observe in any direction is remarkably similar, at least 270 Dirk throughout the Atlantic. Every 93 billion light-years of darkness have this thermal uniformity. It is as if the whole cosmos were a gigantic room, with air conditioning, perfectly balanced. But how is this possible? If the universe has gradually expanded for almost 14 billion years, how can 2 points be more than 14 billion years away? Distance light having been thermally accelerated without violating the speed of light, it is as if two people on opposite ends of the planet could perfectly coordinate their watches without ever communicating with each other. The thermal homogeneity we observe today implies that the universe had this homogeneity from its earliest moments. This was extremely unlikely, considering the nature of quantum fluctuations. In the initial compact prototype, this is known as the problem of homogeneity, or horizon problem. If the universe had been decorated by the interior designer himself, but that designer could never see beyond his backyard. But there are more that challenge our understanding of the cosmos. Primitive, the general theory of Einstein's relativity, describes how massive objects create curvatures in space-time that then govern the movement and the evolution of matter. Within that space-time, stars, galaxies, and black points leave local marks on the structure of space-time. But on larger scales, these imperfections are balanced, resulting in a smoother structure, and like a crumpled bed that's seen from afar, looks perfectly flat, as well as the average temperature of the universe. This softness on a large scale seems to vary very little in the universe. On the largest scales, looks flat. If the general density of the matter in the universe was large enough, space-time would be what we call curved, positively bending on itself like the surface of a soccer ball. This would mean that eventually, the gravity exerted by all the matter in the universe, serious enough to slow down, and finally reverse the expansion trend. This would collapse the universe back on itself, in a so-called Big Crunch. Big collapse would be like watching a Big Bang movie. Reproducing in reverse, all recompressed into a single point. In contrast, if LA was much smaller, would result in a negative curvature of space-time, bending openly as the surface of a... With this geometry, gravity would never exceed the expansion, and the cosmos would continue to grow for eternity. Like a balloon that inflates non-stop until every galaxy is so far away that we can no longer see any. Another which of these general geometries is true has major implications for the future evolution of our process. And that is why it has been the concern of astronomers. Try to measure the general curvature of the cosmos that we can see, and counterintuitivamente appears to be completely flat. And like walking down a gigantic mountain, but only being able to see a square meter under your feet, it would seem to you that the floor is completely flat. As well as the horizon problem, the probability that this is the case is incredibly small for obvious reasons. This is known as the flatness problem. And how to win the cosmic lottery without even having bought a ticket. And there is an additional problem that goes beyond our theories of the cosmos. In the first trillionth of a second, it seems that there are no magnetic monopolies. Throughout the universe, electrical charges exist in positive and negative pairs, cancellating to result in a stable and neutral whole. The magnets are also located at the north and south poles, with magnetic field lines flowing between them to produce a stable and dynamic whole. However, in the universe, we found electrical charges isolated as positive protons and negative electrons. But we never observe magnetic poles for magnets, as if in the world there are only socks on the left foot. You never find one of the right foot loose. Out there, no matter where we look in the cosmos, we have not yet found a lone monopoly without its opposite pair. So it was on a December night of 1979, while trying to solve the mystery of the monopolies, missing, that theoretical physicist Alan Guth found a remarkable solution. His proposal not only addressed the problem of monopolies, but it also solved the problems of the horizon. And the flatness was like finding a magic key, opening 3 different locks at the same time. Good something that instead of gradually expanding for billions of years, the universe may have gone through a period of sudden darkness and almost instantaneous. This inflation mechanism allowed the universe to increase, often its original size in a fraction of a second before slowing down to a more linear expansion. It was as if the cosmos had been a balloon that suddenly someone inflated with a super powerful air pump. The inflationary period, described as good, involved the universe by doubling in size, approximately 90 times, in less than a trillionth of a second. This expansion fundamentally altered the structure of the cosmos, because when the expansion comes into action, things get really big. Very fast is as the compound interest effect, but applied to space itself. Consider folding a giant piece of paper in half and again. And again, if it starts with 1/10 of a millimeter thick, LA Primera doubles it to 2 Colombians. And the next one will take it to just under 1/2 millimeter. A third fold doubles it again, and is now the thickness of a nail. Nothing extraordinary is like stacking sheets of paper on top of each other. But when you reach 7 folds, the single sheet has now reached the thickness of a complete notebook. 10 folds and it will be as thick as the width of your hand. The world record to actually do this experiment is in only 12 folds. In 2002, an American student folded a piece of tissue paper of more than 1.2 kilometers long in a package more than 1/2 meter thick. But if it were possible to make and handle an even more blade, additional large folds would increase the thickness. Astronomically, 23 folds will make the paper about 1 kilometer thick, and 30 folds will be enough to take it into space, rising to 100 kilometers from the surface of the Earth. And how to build a rope to heaven. 1 fold at a time, 40. And 2 folds will take you to the moon in 50. And 1 will take you to the sun 80. And a fold will make that the paper is the width of the Andromeda galaxy, with about 141,000 light years of darkness, and 90 folds equivalent to the 90 duplicates. That good inflation for the inflationary period will transform that unique colossal sheet of paper in a larger folded pile. That the entire Virgo supercluster, with 130 million years light of darkness. This incredible is what Alan Guth called for the whole universe. In less than a trillionth of a second, after the Planck era and the era of the Great Unification, hot, hyperdense cosmos exploded more than an octillion away. Of times, its original size was as if the universe had been a seed that suddenly became a galaxy-sized tree. In the of an eye, it was this marvel, the one who really put the bang in the Big Bang. The universe that a moment before was so energetic, hot, and full now became vast, empty, and cold. This transformation, drastic, is an elegant solution to the three problems that affect. The Big Bang Theory is how to have a machine of time that can solve all of the past. One-time horizon problem. The transaction would have softened any initial irregularities, as if it had been a gigantic cosmic plate. Flatness problem, the rapid expansion, explains why the universe looks flat on a large scale, and how to inflate a balloon so much that any small section of its surface appears to be a flat absence of rigid monopolies. Havana Colombian monopolies. Extremely rare ones. How to dilute a drop of ink throughout the ocean, this paradise. It allows us to consider the possibility that the immense universe that we see is not really everything. What exists is only a bubble of observable universe, whose size is defined by the speed of light. The amount of time that has passed, and the expansion that has occurred since the beginning of time. Thanks to the darkness and subsequent expansion, our observable bubble is about 90 and 3 billion years light of darkness. But it is still only a fraction of the universe as a whole, and is in that invisible extension where the answers to our problems can be found. And like living in a gigantic house, but only to be able to see a room, we know there is more, but we cannot access it. The cosmic factory of reality, the horizon problem, which deals with the thermal homogeneity of the universe. Only a problem if that homogeneity applies to the entire universe. The theory of the universe proposes that the primordial universe, although compact, contained extreme thermal variations. These acquisitions were launched away from each other during the expansion. Is how to, if we had taken a painting with many different colors, and we would have stretched it so much so that now we can only see a small section of a single color, our local part of the observable universe, leaving only a fraction of the total before the disappearance. That fraction was in thermal equilibrium with itself, but other parts of the universe that we cannot observe can be radically different. And how to live in a neighborhood where all houses have the same temperature, but not to know that in other neighborhoods of LA's Ciudad, is it much, much hotter or colder in the same way? The problem of the flatness of the curvature of space-time. It is only an intriguing coincidence. If the observed flatness applies to the entire universe, however, we are seeing only a small fraction of the whole. It is impossible to say whether this is true or not. The apparent flatness may be a matter of perspective. Like when you are in the middle of the ocean, and it seems to you that the water is completely flat, just as the ocean horizon looks flat from the coast, but reveals its curvature when viewed from high altitude. The wider cosmos can be positively curved, negatively curved, or a combination of both. yet we are unable to see beyond our own coastline. Cosmic is how to try to guess the shape of a mountain when you can only see the rock under your feet. And finally, the absence of corporate monopolies is only a problem if we assume they are missing in the entire universe. If monopolies existed in the primordial universe, in the quantity expected by our models, exponential uncertainty would have spread them to the point of being distributed in approximately one per observable universe. And how to search for a specific qualification in a haystack the size of a continent, since we are looking for a single monopoly within a sphere of 90 and 3 billion years light of darkness. It is not surprising that we have not yet found any. The theory of is now an established part of our understanding of the first moments of the championship. Since Alan Guth's revelation, cosmologists have spent the last 40 years investigating the mechanism by which the universe could have expanded so suddenly. And the inflationary period coincides with the fall in energy and the cooling that marked the end of the great unification of the fundamental forces and the emergence of the strong nuclear force. Some scientists theorize that Thetan of particles, boson X messengers that exert the electro-strong force, created a strong radiation field. And as if these particles had been that started the largest celebration in the universe. This field was carried by a new messenger particle, called inflaton. The overwhelming energy of the foam boosted the exponential expansion of the city hall, instantly expanding. Microscopic scale quantum characteristics to macroscopic structures. These transient quantum fluctuations became huge regions of super-energy that would provide the seeds for clusters, galactics and superclusters in the modern universe. All this expansion inevitably cooled and emptied the cosmos, leading to a drop of 100,000 times in average energy levels. Scientists are not yet sure of the exact reason why. The darkness stopped. But when El Campo and the inflaton particle came out, dumping much of that energy back into the universe in a phase known as overheating. This overheating allowed the decisive creation of the material. And now in a larger and more spacious cosmos, the laws of nature began to approach something that eventually we can understand and model. This is the electroweak era, which lasts up to about a trillionth of a second. After the Big Bang at this stage, there are quarks and leptons. Matter and antimatter, all governed by gravity. The strong nuclear force and the electroweak force. However, temperatures and energies are still too high for the strong force to have any real effect on supercharged particles in this post-inflationary wind. Likewise, the electroweak force has little control on interactions between matter and energy. Although gravity may have permeated the universe, since its inception there is a main component still missing, making it almost impotent. Is like having a powerful engine without fuel. Until the newly formed particles are with mass, remain uncontrolled and ungoverned, will lead to another power outage and another cosmological transformation before we reach a universe that we are beginning to recognize as our symmetry is everywhere. Anywhere we look in the nature, we find balance, regularity, and geometric density in our own bodies, or in the bodies of all large animals and small human beings. We are bilaterally symmetrical with our bodies, reflected along a central axis. Our perception of the beauty is often linked to assessing those whose characteristics are most harmoniously balanced. This is not exclusive to humans. Many other creatures, from the imposing whales to the magical worms, share this feature, is as if nature were an artist with geometric perfection. Other animals, such as starfish and sea urchins, exhibit radial with 5 or more rays, radiating from a central point. And this is seen not only in animals, but also between plants, fungi, and even bacteria. Scientists have discovered that the evolution has a clear preference by these balanced and symmetric ways, possibly because they are simpler to construct and replicate. From relatively simple genetic instructions, and it is the mathematical and algorithmic simplicity, the behind the symmetries encountered in the whole natural world. I do not live in the science. Symmetry has a much broader meaning than its everyday use. Means that something is the same. Something does not change, pass. Whatever happens, from the laws of physics to energy conservation and moment, the universe is inherently symmetrical. And like a gigantic cosmic monster that keeps everything in perfect balance. Charges are balanced against negative charges. Some particles rotate clockwise, others in counterclockwise direction. And if you measure the force of gravity in Alpha Centauri, you will get the same result as in our solar system. However, the universe is not perfectly symmetrical. As well as the human body has small asymmetries. Like the heart displaced to one side, the cosmos also presents flaws in its perfect balance. Some particles rotate only in one direction, and there is a remarkable imbalance between matter and antimatter. In addition, there are phenomena that electric fields can cause, that magnetic fields cannot. Despite being conceptually similar, these imbalances are fundamental to the existence of the universe. As we know it, without them, many of the structures and processes we see around us would not be possible, however. Cosmologists believe that for a brief moment, after the Big Bang, everything was perfectly symmetric. For approximately 1 trillionth of a second, there was a perfect balance. But this was broken with the final separation of the fundamental forces and the emergence of a new component essential to the existence. The masses, as if the universe had been a perfect crystal that suddenly cracked, creating all the beautiful tears we see today. As well as the temperature drop causes phase changes in the water, transforming steam into liquid and then into solid ice. Each transition fundamentally alters the properties of the substance and reduces it in a similar way. The decrease in temperature in the young universe triggered phase changes in the energy and the matter, shaping its behavior and structure. And as if the cosmos were a gigantic recipe that changed ingredients as it cooled, as the 4 fundamental forces eventually split, completely and crystallized as separate entities, a new era in the universe has emerged. The quark era, defined for the first time by the interactions of the matter. To understand the quark era, it is useful to consider the different contour scales. Of the largest to the smallest is how to zoom in from a satellite view of the Earth to see the individual atoms on your finger. The largest single object ever discovered in the universe is probably the hypergiant star V. And I listened with a reflection about 1,700 times greater than our sun. If it were at the center of our solar system, its outer edge would reach beyond the orbit of this colossal star. Like all stars, is composed almost entirely of some of the most important things we do. Small that can be found in the universe. Individual atoms of light elements, hydrogen and helium. The hydrogen, the smallest of all atoms, has a name derived from the Greek word for indivisible. However, we now know, thanks to advances in atomic theory, at the beginning of the 20th century, that atoms are divisible. This knowledge was fundamental for the development of some of the most important weapons in the world, devastating in human history. The atomic bomb is ironic that something called indivisible has become the basis for dividing cities. Whole hydrogen and helium atoms, for all their simplicity, are composed of protons, neutrons and electrons that can be processed and handled with relative ease. However, even these protons and neutrons are not the most important fundamental particles in the world, small that exist. Protons and neutrons are composed of even more small, called quarks, is like Russian dolls. Every time you open one, you find a smaller one. The properties of quarks, along with those of electrons, ultimately determine the characteristics and behavior of all the matter in the universe, from the immense star OOPS, and I listen to you. The search for the fundamental particles of matter has been an ongoing and vital mission for physicists in the last 200 years. And like being cosmic detectives looking for the most, to solve the greatest mystery of all. Cosmic awakening and eternal past 380,000 years since the Big Bang. The light finally broke the shackles of the matter. Photons now travel freely through the expanding cosmos. But as the universe expands, its energy decreases, even though it is no longer opaque. The mood is still gloomy. The intense energy of its formation has been dissipated, and it will be necessary to long time until a new process, nuclear fusion, concentrates energy again. And as if the universe had been a gigantic bonfire, which are now just embers shining in the dark. This is the dark age of the universe. There may be little to see, but that does not mean that little is happening during this period. Including the first million years of cosmological history, scientists believe that dark matter enters the scene to shape the future of the universe. Is the invisible architect who is designing the structure of all things to come. The dark matter exceeds the common matter in a ratio of 6:1, but its true nature remains one of the greatest of modern science. But here comes something that fascinates and worries me. At the same time, we are in a composite universe. By approximately 68% dark, 27% dark matter, and less than 5% of normal matter. That means that everything you can see, touch, and experience, each star, each planet, every atom in your body represents less than 5% of your body, of the total reality. And as if we were living on the surface of an infinite ocean, believing that the water we see is all that exists, not knowing the abysmal depths that are beneath. These are the ingredients that have shaped our universe throughout its 13.8 billion years of existence, following the rules and constants that were established in its first moments in the first 13 billion seconds after the Big Bang. Is absolutely amazing to think that the laws that govern galaxies more distant were decided in such a short time that we don't even have words to describe it adequately. The story you just heard is real. Is happening right now. While you rest, there the atoms in your body were forged in the heart of stars, who died billions of years ago. The air you breathe contains particles that have traveled through the cosmos. For eons, you are too much stardust that has gained consciousness. Stardust that can contemplate its own origin and marvel at the magnificence of the universe that created it. And yet, for every answer we have found, 10 new questions have arisen. What dark matter really is? Why the universe is accelerating? There are other heroes beyond our own. We are alone in this vast cosmos. Each mirror shows us how much more there is, to explore how to climb a mountain, only to discover that there is a whole mountain range waiting beyond. Scientists continue to build telescopes, larger particle accelerators, more powerful, and computers to unravel these. Maybe someday, a young mind that is listening to this right now will be the one to finally solve the discovery of the dark matter. Or whoever discovers the first sign of extraterrestrial life. Or whoever truly understands what caused the Big Bang. The most beautiful thing about all this is that the story is not over. The universe continues to write its autobiography. And we are the Germans so much. As the protagonists of this epic story, every day you live, every breath you take, every thought you think, is part of the sequel to the adventure. Most Incredible ever told the story of how the universe woke up and began to know itself. The next time you look at the stars, remember that you are not simply seeing points of light in the sky. You are viewing your family history. You are contemplating the cosmic ovens, where the elements of your body were forged. You are witnessing the most epic story of survival and transformation that has never been told before. You are the universe that has developed eyes to see itself, a mind to understand itself, and a heart to marvel at its own magnificence. If you want to keep listening to these while doing other things, subscribe now. For in our next Cosmic, we will explore something yet more mind-blowing, like those first stars began to shine in the dark and forged the heavy elements that made planets possible, like the Earth and eventually life itself. The history of the universe is just beginning, and you are an integral part of that story, which continues to be written at this very moment, as you hear these words in this special corner of the cosmos that we call home.